All right, welcome back. One-sided limits and infinite limits. All right. Well, we said, the limit as x went to a of f of x was L. What that really meant was that as x got closer and closer to a, that f of x was getting sort of closer and closer to L. But x can get closer to a either on the right or the left. And there are times when you want x to approach a just from the right side or just from the left side. So if you want x to go to a from the right side, only, then you write x converges to a with a plus. The plus meaning from numbers slightly bigger. If you want x to go to a from the left side only, then you write x goes to a minus, meaning head towards a, but from numbers that with a little bit subtracted off from them, so they're to the left. Okay, they're called one-sided limits, and you can do this with a picture example really well. So suppose f looks like this on this side, but over here it looks like this. Say this is the number +1, this is the number -2, whatever. Then you could ask about some one-sided limits. You could ask, what is the limit as x goes to 0 here from the right? Well, if you're going to 0 from the right, that means you're on the right side of 0 here. And when you plug x into f, you see that f of x is getting closer and closer to 1. However, if you do the opposite, you approach 0 from the left-hand side, well then, here would be x going to 0 from the left-hand side, and as x does this, then f of x would be zipping along like this, and it would be heading towards -2. So you see the right-hand limit can be different than the left. And in this case, just the pure limit doesn't exist. The limit as x goes to 0 of f of x does not exist. And that's because if you put no constraint on how x can approach 0, it can approach from the right or the left. And then it's not getting close to a single number, because when it's a little bit on the right side, it's trying to get close to 1, but when it's on a little bit on the left side, it's trying to get close to -2. And you can't have a schizophrenic limit here. So the limit doesn't exist unless you approach just from the right, so the right-hand limit exists, or from the left, and the left-hand limit exists. All right, there's one more scenario that we're going to talk about here, and that's called infinite limits. We say the limit as x goes to a of f of x is infinity if, as sort of x is getting closer and closer to a, f of x gets bigger than any number, any fixed number. Okay? In other words, as x is going to a, f of x is sort of zipping along to infinity. You can also head to negative infinity in the same way, in which case you get smaller than any number. Technically, this is a type of limit that says the limit doesn't exist, because the original definition of the limit, you had to get close to a number. And this is not happening here. It's not getting close to a number. So the limit does not exist. But within the realm of failing to exist, we give a special name to this one where it blows up without bound, and say that the limit is infinity. Okay? Let's do an example here. And you can combine this with the right and left hand side. If you look at the function f equals 1 over x, its graph looks like this. Okay, and it's pretty clear that if you take the limit as x goes to 0 from the right side of 1 over x, from the right side, this is x is going to 0 from the right hand side. As x heads towards 0 here, f of x will zip along this curve here and blow up to plus infinity. It just gets bigger and bigger and bigger. Whereas the limit as x goes to 0 from the left-hand side, so this would be x going to 0 from the left-hand side, as x zips along this way, then f of x zips along this curve and heads off down to negative infinity. Okay? All right, that's infinite limits and one-sided limits. Ciao.